A sip of alcoholic beverage triggers almost instantly in our bodies a complex chain of reactions through which the body attempts to break down alcohol, this foreign and toxic substance, for humans and render it, as much as possible, harmless. Does it succeed? Here's what happens during the journey of alcohol through the human body. Why do some people enjoy drinking, while others do not? Alcohol lingers in the mouth too briefly to be broken down by salivary enzymes, except to a very small extent. The majority of ingested alcohol passes into the stomach, where the major transformations actually begin. Two types of enzymes participate in breaking down alcohol. The first type of enzymes, called alcohol dehydrogenases, ADH, are found in larger quantities in the stomach and convert ethanol, ethyl alcohol, into acetaldehyde. Acetaldehyde is also toxic to the human body, so it needs to be further metabolized. This process takes place in the liver, where the second class of enzymes comes into play. After alcohol ingestion, the liver quickly gets to work neutralizing the poisonous acetaldehyde. This occurs with the help of enzymes called aldehyde dehydrogenases, ALDH, which transform acetaldehyde into acetate, a harmless compound. So, at first glance, the human body seems well equipped to handle alcohol consumption, even though this compound is toxic. However, as usual, when we look more deeply, moving from the level of organ physiology to cellular and molecular processes, things become more nuanced. For example, how do we explain that some people have a remarkable fondness for alcohol, being able to consume large quantities without showing signs of intoxication, while others end up under the table after just a few drinks? Firstly, not everyone has the same enzymatic makeup. Both ADH and ALDH are enzyme classes that consist of several subtypes, and the synthesis of each enzyme is encoded by a gene. We don't all have the same genes. Rather, we possess different variants of the genes involved in the synthesis of these enzymes. As a result, some individuals may secrete larger or smaller amounts of one enzyme or another, and these enzymes may be more or less efficient in metabolizing alcohol. Secondly, the liver also has a limit, meaning it can metabolize only a certain maximum amount of acetaldehyde per hour, depending on the quantity of ALDH available. When its capacity to break down acetaldehyde is exceeded, this substance accumulates in the body, leading to very unpleasant effects. In some individuals, the poor functioning of enzymes causes the second phase of alcohol metabolism, the transformation of acetaldehyde into acetate in the liver, to proceed with very low efficiency. Consequently, the accumulation of acetaldehyde in the blood produces effects such as increased heart rate, profuse sweating, flushing, nausea, and vomiting. Alcohol tolerance, therefore, depends greatly on individual genetic makeup and is influenced by other factors, such as age, sex. For example, young women have a lower alcohol tolerance than men of the same age, the overall health of the body, and the quantity and type of food consumed on a given day.